Welcome to Exploring Pitch, Results and Explanations. Pitch is how high or low a sound wave is. We can say that a high frequency wave has a high pitch and a low frequency wave has a low pitch. Let's revisit our pitch labs to find out our results and see if we can make some conclusions. First pitch lab was bottles. How does the pitch change as more water is added to the bottles? This one has a little bit of water. This one has a little more water. Still more. And this one has the most water. Did you hear the pitch get higher as we added more water? So more water equals a higher pitch. Less water equals a lower pitch. Let's explore our results from lab number 2, comb. As you listen to it, think about how does the pitch change and what causes those changes. This one's kind of a tough one, but the thinner teeth are what produced a higher pitch, and the thicker teeth produced a lower pitch. Let's discuss our results for lab number 3, glasses. And I want you to be on the lookout for how that pitch changes and why it changes. Okay, I'm gonna do it again. Yeah, so as you guys hear it, it's low here, and it gets higher as we get less water. Now these results for glasses are different than our results for bottles. In Lab 1 bottles, more water gave us a higher pitch, but in our glasses lab, more air or less water gave us a higher pitch. The bottles lab gave us a lower pitch when we had less water, and our glasses lab gave us a lower pitch when we had less air or more water. Why the difference? It's all because sound was made differently for each lab. The bottle sound was made by vibrating the air, and the glasses sound was made by vibrating the glass. Let's explore another pitch lab that creates sound by vibrating the air. It's lab number 4, straw flutes. Make sure to look out for how the pitch changed. What caused the change in pitch?
You got it!
You got it.
I know Mr. Allforce wasn't the only one to hear that the shorter the straw, the higher the pitch, and the longer the straw, the lower the pitch. Pitch lab number 5 is Boomwhackers. Pay attention to how the pitch changes. So listen. So as we went from shortest or longest to shortest, look at the difference in length. Everything else is the same. Listen to the difference in sound between those two. So can you hear a difference? This one is much lower than this one. This one's much higher. So for lab number 5, our Boomwhackers, the short Boomwhacker produced a high pitch and the long Boomwhacker produced a low pitch. Let's check out our results from lab number 6, instruments. How does the pitch change for each type of instrument? First up is the xylophone. I even have one that's kind of like for a little kid. So for the xylophone, a high pitch was produced by hitting a short bell, and a low pitch was produced by hitting a long bell. Let's go ahead and see the panpipe results now. Makes some sound, some music. That was the longest one. Now this is the second longest. Let's see if you can hear a change. A high pitch was produced by blowing over a short pipe, and a low pitch was produced by blowing over a long pipe. A high pitch was produced when the slide was all the way up, and a low pitch was produced when the slide was all the way down. Lastly, we're going to go ahead and look at the results of the kalimba. So this one's the longest, and then I'm going to go shortest. Shortest, longest. I had to pluck different tines to produce a sound on the kalimba. The shorter tine produced a higher pitch, and the longer tine produced a lower pitch. Let's go ahead and review our results. A higher pitch was produced with a short bell, a short pipe, the slide all the way up, and the short tines. A low pitch was produced with the long bell, the long pipe, the slide all the way out, and the long tines. What type of observations did you make? So based on what you know, if we were to strike these two tuning forks, which one would make a high pitch? Which one would make a low pitch? Why do you make that prediction? Let's test it out. First up is the long tuning fork. Could you hear the difference between the two tuning forks? Let's listen one more time. The tuning forks with the shorter tines produced a high pitch, and the longer tines produced a long pitch. Pitch can be shown by drawing wavelengths. The wavelengths that are farther apart would produce a lower pitch, like the one on the left, and pitches that are high would have wavelengths drawn really close together. That would produce a high pitch. Let's explore our results one more time. When we see high pitches, we can see that the wavelengths are closer together or have a higher frequency. High pitches were produced with short straws, the slide up, the short boomwhacker, the short bell, the full bottle, with a small air column, the short fork, and an empty glass. We could also say the short panpipe produced a high pitch. A low pitch was produced with a wavelength that has a low frequency, or it's very spread out. We made low pitches with a long straw, our slide out, a tall boomwhacker, an empty bottle, so that had a very long air column, a tall fork, a long bell, a full glass, and also the longest panpipe. I can see all of the high-pitched items had things that were short, causing the frequency to happen more often. And all of the low-pitch items happened less frequently or not as often. That's why everything was long. What connections did you make? All right, that's all for me. Take care. Peace.